did that, just sort of self-evaluated then. So, I nearly said it. Cool, can I get someone to, one of the organisers, one of the staff members to come and help me draw out some names out of hats to give free things to. I don't really mind who. Come on, Amy, you can do it. You did it yesterday too, you were good. All right, so how are we going to do this? Okay, so up for grabs first, we have, I'm not even going to make the megabyte joke today. We have another portable hard drive. Yeah, Western Digital, quality sort of a hard drive. It's quite a useful thing. You could store lots of Breaking Bad on that. Let's be honest, this is what you're going to do. So let's draw a name out of the hat.
Someone want to hold it?
I could be rigging it. So can we get a volunteer to come and help us, please, if that's okay? Sick. Oh, not sick. I mean, okay, that's okay.
All right. Manuel Silva.
Hey. Okay, we've got 2 books to give away, so we're going to do 2 draws for these ones. The Year Without Pants, which is a book by Scott Birkin, WordPress.com and the Future of Work. So that could be quite interesting, actually. Can I keep one? Do we have to draw both? I might keep one of them, but we probably should draw both. So the first winner is
Ryan May.
Ryan May.
Yep.
Ryan May, you here?
Redraw.
What's the rules? Are you just a redraw if they're not here? Yeah. I think that's the case.
Sebastian Mature.
Yay.
Jonathan Mullins.
Jono.
Just talking to the guy.
He's going to regret going to the toilet now, isn't he?
Chris Biggs. There you go.
It's becoming more obvious that this next one is actually better for me because of all the amount of running I have to do around to give you out presents. But we have... I did that yesterday with the Fitbit, didn't I? I hit it on the mic, I'm sure I did. We have another Fitbit Flex, which does all the tracking, as I said yesterday, day and night and early evening, late evening, early morning. Doesn't do 12 till 2 though. So we have, the winner is...
Nicholas Dijux.
Very nice.
Oh, we have one more?
We have one more.
Oh, there's one more.
We have a genuine JB Hi-Fi bag for anyone, full of about maybe 4 litres of Sydney air, if anyone would like this. I don't really want it. Jokes aside though, that's the giveaways, so congratulations to our winners. Right, so we're going to have one more talk now, and then I'm just going to get up on stage and tell you a few more things, and some of them are really cool and involve beer. So bear with me for one more thing after this talk. But first, David Zook from Heroku is here to discuss designing HTTP interfaces and RESTful web services, so lots of API goodness. And yeah, welcome. Thank you very much for the last talk of the conference. Thank you.
Okay. Hi. Good Friday. This talk is called Designing HTTP Interfaces and RESTful Web Services. I hope you can hear me loudly enough. If not, throw in a soft object at me. My name's David. I am German. I work for Heroku. where I don't do anything anymore related to APIs or HTTP or REST. So maybe all this advice is incredibly outdated and you could just ignore me. But if you'd like to ask me questions or comment on this talk, you can send me an email. You can also shame me publicly on Twitter for the next 40-ish minutes because I can't respond and defend myself. Quick show of hands, who thinks they could describe what REST is about to me? Oh, that's not a lot of people. Okay, good. No. So you are humble, smart and humble. That's good. I, for the longest time, had no idea what REST really was and how this all worked. So that was back in a time when we all probably, or many of us, first started web development. So before REST was even a thing, everybody used like some sort of portal software, channeled everything through index.php. We only used HTTP as a means of, browser talks to our web application, and the application was something funny but not very useful and implemented in PHP, probably very poorly. And at some point, people figured out, oh, hey, we can make money on the internet. And with that came search engines, and with that came the people, they call themselves SEO consultants or something, and they said, you can't have URLs like this, right? Verboten, the German ones anyway. So we had to make we had to SEO friendly our URLs, right? Like this, even the domain and the part of the URL, none of this even matters anymore today to Google. But back then, people believed it did. And if you ever want to be really rich in life, you should become an SEO consultant. I used to work for a company. They had an SEO consultant, and only the boss of the company could send a question to the SEO consultant, who was mostly on some sort of spiritual mission somewhere on an Indian island, and charged 4,000 euros per question, and would never disclose his data that he used to make recommendations to us, which were very ridiculous. So we had URLs like this, right? And basically rewrite away the index.php. And then Ruby on Rails showed up, and everything was a parameter in the URL, and things horribly spun out of control because nobody really had a clue what they were doing. So you would check out the latest hamburger videos or the latest video hamburgers, and then search for pictures of cats in some sort of descending order with a limit of 200, whatever that means, right? And at the same time, everyone said, oh, you need to have web services, like you need to have a layered architecture, service-oriented architecture, right? That's the same as microservices, except you don't implement it all in Java, right? So like this is the, I mean, I've been in tech for long enough. I've been doing this professionally for long enough, and I can tell you, it's all a circle of shitty buzzwords. And it all comes back every 10 years. So back then we had something they called SOAP. Remember SOAP? Whoever had to use, like, write or read or consume a web, okay. So you probably really suffered from this. And in many cases, SOAP was a lot harder than it would have been, than it had to be. SOAP, if done properly with a proper schema and all the descriptions, was actually relatively simple. But what people did instead was send XML that they passed using regular expressions back and forth over the wire. So you would request a product, right, get product, and here's the ID that we're getting. And then somewhere in a schema, it says there's a get product response object that has 3 fields, and this is the red stapler for 3, no currency, money, 14. And so the information about the operation that we're trying to perform here is encapsulated fully in the post body. You have to post to the endpoint, and while the serialization format and the encapsulation of the operation is standardized in SOAP, the actual thing that we're trying to achieve in the business logic, in the business domain, which is getting the product, is only known or understood by client and server. No intermediaries. And if the product didn't exist, well, that was exactly the same, except that it returned a fault code of some kind. That's how you communicated error conditions, which was also very, very difficult if you remember that. the only actual concession that, in this case, SOAP made was, oh, clearly the product doesn't exist, must be an internal server error, which is nonsense. But anyway, they decided on that. So it's a 500 internal server error, but that was just if you did it over HTTP. You could do SOAP over SMTP. There was a standard for that, which is crazy. Sockets and everything else. So after a couple of years and too many crashed Tomcat containers and consultants who got rich off JBoss, people said, oh, SOAP is stupid. Let's build something really simple. So I saw that you all spend a good amount of your time, which is great for us speakers, reviewing these presentations of the conference on Joined-In. So Joined-In used to have an API that looked like, this is the old Joined-In API. The new one is much better. So the old Joined-In API, you would make a request where you have some sort of envelope, and you could authenticate also. Chuck Norris doesn't actually obviously need a password because he gets in anywhere for free. But and then you have, again, some sort of element that says, get me the details of something. You pass the ID, and it returns you a response. And that's actually the exact same thing as SOAP. The only difference is that none of this is standardized, whereas SOAP was. But so if you look at this API, it performs a post to get a product. So it's not cacheable. Even if you wanted to cache it, say you take some sort of custom software or a Squid or something else in between client and server, it all of a sudden has to understand if it's a post to that endpoint and it contains that action and the response is successful, then I can cache it. But for that, I need to implement some sort of logic that parses that vendor-specific XML. That's nonsense. But people did that anyway. They called it RPC something something, and 2 years later, they started sending JSON over the wire, but this principle was equally stupid. You cannot cache this. It's always a post, so all the intermediaries need to assume it's an unsafe operation. It doesn't use HTTP authentication, but instead, Chuck Norris has to authenticate through a custom mechanism. And all the information that anybody along the wire, along the communication chain, needs to understand about this operation is vendor-specific in a custom format inside the request body. That doesn't work. There's a guy called Leonard Richardson. So who has read, here, what's his name? Martin Fowler's Patterns of Enterprise Application Architecture, rings a bell? Yeah, so lots of design patterns. You can make factories or problem factories. That's a nickname for Java. So he's very smart. He wrote a lot of books on really good, like how do you design software properly? And he knew this guy named Leonard Richardson. He happens to be one of the co-authors of the first HTTP specification. And this Leonard Richardson, nice guy, now wrote his first novel about space. And he once made a set of 4 rules describing how mature an API is in the REST model. How RESTful is it? Being a programmer, clearly the indexing starts at 0. So he called it the Richardson maturity model. That was Martin Fowler did that on Richardson's behalf and said, level 0 means you send XML or JSON or CSV, or it doesn't matter, over the wire. And it's like calling remote procedures. You invoke the remote method get details or get product, like with SOAP. And you could improve that by giving each resource its own URL, but that's not actually an improvement, so don't do either of those things ever. Some years pass, and then people all of a sudden started talking about Roy Fielding and his dissertation, and he coined the term REST. Right? That was really great because all of us could say, I have a RESTful API now, when in fact we actually didn't have one. So REST means representational state transfer. That means I transfer the state of a resource through its representation. That's conceptually simple, but because it was hidden in a lot of words in a very boring dissertation, I tried to read it 4 times and fell asleep every single time. People actually didn't get it. So he described it in this paper, and it's actually so have a morning coffee, then read it instead of trying, it's not good bedside lecture. And in this paper, he defines a bunch of constraints for network-based software architectures. It has nothing to do with HTTP. It just happens that HTTP's paradigms map really well to REST, right? So you want a client-server architecture. For us, that's relatively straightforward. All the requests should be stateless, so there is nothing inherent in the protocol that says, oh, this is the second or third or fourth request the same client is making, and through some sort of JSession ID cookie, I magically know that, right? Things should be cacheable. They are also cacheable because we have a layered system. If I have a client and a server communicating, and there's proxies in the outgoing direction or inbound proxies called reverse proxies, anywhere in the chain, these are completely transparent to the communicating parties, the client and the server. That's what enables cacheability. If you want to ship JavaScript to the browser to make flashier websites, you can have code on demand. Let's ignore that because machines don't need this. And there is a uniform interface that we need to follow in order for something to be RESTful. Now, the uniform interface says a URL is identified through its resource. A URL identifies a resource. And with a method, get, post, put, delete, you perform an operation on these resources, right? And this operation is always implicit from the request line through this method, the verb. I delete /product/coffee, then the coffee is deleted, right? And to communicate between client and server, I have and this is where REST becomes RESTful, a hypermedia format, and I use link relations for navigation. Those are the two parts everybody ignores and still calls it RESTful. But those are also the two things that make it incredibly powerful. I'll show in a moment. But before we dive into this part, I want to talk about that part. In particular, URLs identify resources, and a web page, for instance, is not a resource. A web page is merely a human-readable representation. It's actually not a human-readable representation, it's a browser-readable representation in HTML. And the browser makes something that has lots of colors and text, and you can read it, right? So it represents the resource in a specific format. If you want the list of products as JSON, you can get it as JSON. You simply say in the client, I accept only this format. You can do the same as XML. Neither of those are hypermedia formats, because all this says is it's encoded as angle brackets. All this says it's encoded as curly brackets, and no parser in the world can tell you where you missed a comma. Right? That's the main difference between JSON and XML these days. So those are not hypermedia formats because they have no attached meaning. Application /vnd.com.acmeshop plus XML would be a hypermedia format, because then somebody takes a spec and says, look, there is a product element, and there is a price element, and the price element means this to you as a human, also you can put that knowledge into code. We'll talk about this later. HTML is also, well, HTML is a hypermedia format, but really it doesn't convey semantic meaning of the content. It's more like semantic meaning of the markup, right? So to say, okay, there is maybe an unordered list, but that still doesn't tell you that that list is describing a list of products. But it doesn't have to, because it's a browser rendering it for human consumption. And humans have a very cool feature, it's called a brain, and we can understand from the context and looking at it, I mean, unless we're really drunk or something, that this is a list of products because it says so, and that the red stapler costs €3.14. So, to design an interface where this works, not the hypermedia part yet, we first need to think about how do we even build a plain HTTP interface. And I usually like to start defining the resources in my system. So what's actually the stuff I need to expose in my API if I build an API? And people sometimes do stuff that's all over the place with products, and you can filter them somehow. And is that the product or the photo ID? And you can make a new product or a photo, and which is which. So structure is, this is a slide, 2 slides later, I'll say it now. This doesn't actually matter once you've built a properly RESTful system. What your URLs look like, they could all be UUIDs. But it helps you as programmers to think in structure terms and then more consciously expose the information in your system and what are actually the points and the entities that you want to expose for interaction by a client or possibly other servers. So if you want a list of products, then you can use a query string to filter on it, because that's what the query string is for. And then you make an individual product, and it may have a collection of photos as a child that you could, again, filter on and address an individual photo. Like I said, later on that won't matter, but still follow it because it's nice to think of, to have a nice structure before you start coding. So once we have these resources defined, we would like to get, for instance, the products, and that gets us a list of products. Now, when I post to the list of products, what happens? Create a product, correct. That returns what? Status code? Very good. And what else? Location header, yes. Good. So, very good. Why are we here? Let's go drink beer. You guys already know everything. An individual item, I can get to retrieve it. I can put to update it, and the put needs to be complete. Now, if you say, well, my products are 500 megabytes each, and I really only need to update the description very often, so I'm going to go through all the pain and implement this weird patch method, please don't, because it's a bag of hertz, and it's never going to work properly. Instead, you could have a products 1234/description. That's its own resource. Put to that to only update the description. Little hacks from real life. Delete it to delete. That's now a level 2 Richardson maturity model interface. We use HTTP verbs, get, post, put, delete, and we have status codes to indicate the success of an operation. For instance, we could say, that product is way too cheap for that category, so that's a conflict. Now, there are a bunch of really, really popular APIs out in the wild that get this so absolutely wrong that it's painful. Who uses the Twitter API ever? Maybe, probably a few of you. OK, it's not hard to understand because, you know, tweets, we all know them. So we're not looking at the hypermedia-ness yet, restfulness, just HTTP. So you show a status. You actually get it. And this, so this is the implicit in the operation, right? A get means showing. I can post to update statuses. I'll let you guess what that does in a second. First of all, I can't, with an accept header, say I accept JSON. It needs to be a URL parameter, which is really bad for content negotiation. Really bad for proxies along the way, which need to understand what type of format this is before they even pass the request to the backend. They need to parse the URL. If Twitter wants to do an XML format of their API, a proxy that caches outgoing requests to the Twitter API needs to pass the URL and say, depending on .json or .xml, I return something else, which is kind of implicit in HTTP. Every URL is a different resource, but anyway. Now, you can delete, destroy, clearly the status, and you can get retweets. You can make a retweet, and why would they use the same URL for that? But the most important thing, besides this being a put, is that there's something wrong with this part. And maybe one of you could tell me what it is. So first of all, guesses. What does that do? Well, yeah. No. I mean, in the Twitter API. That's how you make a new tweet, because clearly you update something to make something new. So and this is an important thing about RESTful APIs, is if you follow the rules, it's actually pretty cool, because you give a developer two things. Here's my media type with all its fields. This is what the documents in the system look like, and you document those. And you give them one URL, /. They fetch that, and you have all the links to all the other parts in your system. And I, as a human, when learning the API, I can follow these URLs, and it returns me a document in a format that you have described to me, and there's more links that I can follow, and I'll find my way around. But if something is called update and actually create something new, that's going to be really difficult for me to learn, and then I'm frustrated, and then I have to give presentations about how bad it is. So there is a thing missing. There's a thing missing in that URL. One very, very, very important thing. I want to make a new tweet. What's missing here? User ID is missing. Right? Remember, this doesn't update a status. This makes a new status. But for who? It implicitly uses the authenticated, the currently logged in user. You authenticate as one user, and you always make all the operations on the API as that user. So they can never implement delegation. It would be about time that, 50 people manage a big company's social media account, they all have their individual Twitter accounts, so they don't have to share the passwords for one Twitter account, and then they get hacked, which means somebody used a lame password, and people post funny stuff. But instead, I could have access to some company's Twitter account through delegation. They could say, David is allowed to post tweets. And I, with my credentials, could post to statuses / company or something. Company / statuses might be better, right? Could be a lot simpler. So you have all the statuses for a username. You make a post to create a new tweet. You have an individual status, and if you delete it, you delete it. You could say a put within 10 seconds, you can fix a typo. And a list of retweets you can fetch, and if you post a put to it, you make a new retweet. But that would have been too simple. OK, so enough bashing Twitter. I want to go back to the very beginnings of the web. The web is the World Wide Web, right? That's the www part we enter in URLs. It's an information exchange system, and it's the first that we have that seamlessly and seemingly effortlessly spans an entire planet. That's Earth from space, in case you don't know what planet we're on. I think that's Apollo 17 or something, blue marble. Anyway, why is that possible? Why have we got a web where you can have billions and billions of websites without its structure collapsing underneath it, right? There's been systems in the past, Gopher, for instance, that could not have scaled to this size. And the answer is the hyperlink. And specifically, one feature of a hyperlink. I can link to something, and that destination doesn't have to know about it. There is no tight coupling. The World Wide Web was invented by egghead scientists at CERN. Actually, Tim Berners-Lee doesn't have an egghead, but he's a scientist. So scientists really like research papers and references and citations. And sometimes, in a bibliography or something, or in a research paper index, you'll have information about a paper and what other papers it references and what papers it is in turn referenced by. So you have this web of references because that's really important to find new information. And in a very early draft of the HTML specification, I think it was actually mandatory for any hyperlink to have an inverse relation to it, an inverse link attached to it. So you know that this link is linked to from somewhere else, or a page would have to have links pointing to it. Luckily, they never built it that way. They instead made it loosely coupled by design. So when I want to link to google.com, I don't have to notify them that I'm linking to them so they can link back to me. I can also link to someone else's website. And if that website disappears, or if that person deletes the document on their website, then I get a 404. Because the World Wide Web is made to embrace the possibility that there's going to be failures, right? And that means I can add information to the system without adding friction to the system, other than for us humans to find the greatest cat GIFs. That's clearly a challenge, but that's why search engines exist, and now Google knows everything about us. But in principle, this loosely coupled design means there is no limits to scalability. We all just follow a bunch of hyperlinks, and sometimes stuff breaks, and we have to cater for that situation. And maybe the information behind this hyperlink changes, but because we're all humans and we drive the interaction through a mouse or keyboard, touchpad, whatever, smartphone, we figure out, oh, my favorite, like the sports column on my newspaper website has changed, so I need to click some other button now. That's really cool. And I'm going to talk about what if machines could do that. The uniform interface I mentioned earlier, we said we identify resources through a URL. Doesn't have to be a URI, but could be. In the case of HTTP, it always is. And the representations are conceptually separate. We manipulate through the representations. That is, the representations are complete. I can't have a partial update with a put. That's important for the integrity. It's important because I can say, hey, server, update this document, but only if the version you have is the same version as I have. I can do that with an if match or if modified since header. Right? It's called optimistic locking. Again, scalability. Very cool. Anyway, the messages are self-descriptive. Anything a server client needs to understand about a format is encapsulated in headers and the request body. And we need to use hypermedia as the engine of application state. Now, it's a very evil, angry acronym, maybe invented by Germans. Hate us. So, a bit of a nasty acronym, but so anybody ever heard of hypermedia as the engine of application state? All right, I'm going to try and explain it now. So the question is, if I have a client and a server in an API, how does a client know what to do with a representation or how to follow links so I can fetch the next page of search results? How do I know how to make a new resource? Where's the whole contract? SOAP used to have a contract for an API, but it only was a description of how what the data looks like and how you invoke an operation on the remote. So you say, there is a get product operation, and it requires one integer as a parameter. It returns this object or this data structure with 3 fields in its response. What it didn't tell you was you need to call create product with a bunch of product details that look exactly like this. It was an XSD schema that would say 10 fields for a product. Send these 10 fields on the create product operation. The create product operation then returns you an integer, which is the product ID. You then take this integer and pass it to the get product operation to fetch the details about the product you just created. This flow was not documented anywhere. You had to put that into human words for a programmer to understand. But it wasn't described in the service contract. The WSDL file and the XSD only described how to invoke these operations, but not what they meant and what the flow was. So can we teach a machine this flow, at least in a basic way? That's what hypermedia as the engine of application state is about. We use links, and these links are used by clients to follow a list of search results, for instance. And they don't need to know these URLs in advance. They don't need to a lot of APIs these days are documented in a way that /people and then curly braces user ID. And you hard code that into your client. That's really bad design because the server can never change that format of URLs. And somebody else who doesn't very much like that URL schema or can't follow it for some reason can't adopt the same API standard. It creates a bunch of walled gardens and silos where people say, this is my hard-coded stuff and this is somebody else's hard-coded stuff. They do the exact same thing, but they're slightly different, unfortunately. Excuse me. So we can't share. We can't build an interoperable client. We can't build a proxy that can cache both easily. So we want to abstract the whole application workflow, and we want to use as a last resort mechanism versioning for the media type itself in order to allow the interface to evolve with breaking changes over time. So I already said XHTML would be a hypermedia format. Atom is a hypermedia format that describes a feed of items to read. That's in very many cases actually not that useful because you actually want to convey the business meaning of your entities in your problem domain. So you could also roll your own media type, and I made an example media type for a shop, okay? So I can fetch a certain product, and I would document the meaning of the elements in my API documentation. I would say an ID element, name, price, clearly, link, rel, payments. I would have /products, which is a list of all the products, and that would basically be just an item products and 500 links to my 500 products. Link rel equals product. And because I documented in my API docs what that link relation means, it means it takes you to a product. A client can say, fetch me all the links that have a product relation and fetch those, for instance, if I want to write a little bot that goes through a shop and indexes all the products, right? You can do a bunch of fancy things. In the case of XML, you can reuse my laser is not working. Oh, there we go. That's better. So here's the laser. You can do a bunch of clever things that don't really matter. But what you have achieved now, no, they're not that important. I'll show some better examples in a moment. So now you've achieved level 3. You do all of the level 2 things with a nice HTTP usage, etc. But you're also using a hypermedia type and documenting what the type means. And now I can write a client. And all I have to know is the basic HTTP semantics, meaning if I, instead of getting this product, I put to it, that means I update it, right? And I know what the document needs to look like because you told me in your media type documentation. So in this example, I chose XML. I chose XML for a specific reason. It has a bunch of advantages over JSON if you need to interact with other people. Hyperlinks are predefined. You can namespace everything, attributes and elements. JSON is a bit more difficult because you have a lot of collisions. You can't stream it. It's, in some circumstances, not as human readable, but most importantly, it's actually not forward compatible for changes the way XML is. That's the whole X part about XML, the extensibility. Some examples. So if we have a product, has a price, right? A bunch of links here. And I now want to add currency information to my price, and potentially have a list of prices. Any client that's written against this JSON assumes this is a float. Any client written against this XML fetches the first price element in the product because that's how the DOM works. That's the document model of XML is from the product, fetch the price. There's always a collection, could be many. So I fetch the first one, and I get the element content. So when I later add a currency attribute, my code doesn't break. My JSON code that expects a float here does break, right? And I could also, or if I made this a list of objects, which obviously would be a lot smarter, it's the same story. I have 2 prices, right? That doesn't break existing code out there. So versioning an XML document model, if you have bacon and you say it costs $5.99, then you want to just add some information that bacon is really delicious. And later on, you add currency information and then additional currencies. All these variants of the same document can be interpreted correctly by the code that parses this, because it says, from the product, the first price element is the price I'm looking for. And it's still the correct price, it's still the correct price. And even when I start adding some alternative names, right, Speck is the German for bacon, the code still doesn't break. So consider that. For the love of God, please, if you control client and server, mobile app, or it's your own web browser, please, please, please use JSON because it's gonna, save your sanity. But if you have to evolve something with many, many parties involved, if you wanna evolve it over a longer period of time, think about XML. It's not a stupid format. It's not worse than XML, than JSON. And sometimes maybe you even write an HTTP interface that isn't actually RESTful. That can never be RESTful because of what it does. File storage would be a good example. So S3, or any CouchDB users in the room? No, CouchDB is great. So if you ever need a document storage, use CouchDB. But so CouchDB or S3, you send them some information that they just store for you. The server doesn't actually understand what you're sending it. S3 stores for you in its REST interface text files, videos, cat GIFs, music, and it doesn't care. It doesn't understand what's in it, right? It can never expose a hypermedia format for you when you fetch that information. And luckily, they don't call it a REST API, and neither does CouchDB, actually. But the idea is that ultimately, when you follow these principles, you have a document like this, and your client becomes a state machine. Because the idea is this, and I've implemented systems like this in real life, so this is not theory. This actually makes everybody's life easier. I want, in this case, I'm searching for sharks because sharks are clearly amazing. So the search query is sharks, and I'm on page 1 currently. So link rel equals self. The self link relation meaning is defined in a global specification by the IANA. That's the Internet Assigned Numbers Authority, maybe. And what next means is also clearly defined. Self means the element I'm in is identified by this resource. So I could have a self link in each of these products, and my client would know how to fetch that product. I now also know how to go to the next part of this list of results by following that link. So if I want to ingest all the search results for that query, I write a simple while loop that fetches the new results until there is no more next link, because then I know I'm at the end of the list of search results. Think about how much easier that is than all the XML and JSON APIs out there that would have a number of search results, current index, and like 7 elements, and then some URL template somewhere in the documentation that says these parts of the URL need to be replaced with these parameters. That's useless. That's not even necessary. You can do it that way, and that actually works. Link everywhere. Don't expect your clients to hard-code their URLs through some sort of magic schema that you predefine. So there used to be a video rental and streaming service in Europe called LoveFilm. Was eventually bought by Amazon. They now use it to power Prime. Basically the same as Netflix, except it doesn't exist anymore. So they had a really cool API. Their API has some faults, like this should use some XML namespace, because then you can throw other elements that also called total results in there from another namespace and nothing ever collides. And a mobile client downloads the first couple of bytes here, sees it's a search element, so that's what I expect. So I continue downloading 3 megabytes of search results. Again, something, by the way, that sets it apart from JSON, where the _type : search results key could be at the end of your 10 megabyte document. So you wasted all the bandwidth and time on a mobile browser download. Anyway, so here I'm searching for old in their games catalog. And Star Wars Knights of the Old Republic, I hear it's a pretty cool video game from 2003, so clearly this is a very modern example. This is how I go to the current search result page. This is always useful, because you can take this document, store it somewhere in a database for later processing. And the worker process that processes this document fetches this document and immediately knows how to address it, right? You don't have to also store the URL to that document with it. If documents are self-contained and self-identified, you can do that. And now, because it's a list of many search results, as we see here, it also provides me with a next link. And here's also a last link if I wanted to go to the last operation. But again, I can go through the whole catalog by just following each next link. And then, because I have just one item per page, I have just one catalog title in here. Its ID is actually the URL. And in here is a link with a rel, and this rel is not a short word like self or next, because these are globally defined. There's one global namespace for the whole world for link relations. So you shouldn't make up one that's called product. You should call it something.com/something/product. Something inside your domain so it doesn't collide with others. So if a client wants to process this information, it fetches the catalog title, finds the link with the rel reviews, and then follows that link to download all the reviews for that video game. And this reviews link, again, could maybe contain 5 reviews and a next link because there's more than 5 reviews, right? So it could ingest those again. And because they got bought by Amazon, Amazon could have at any point have decided, instead of linking to LoveFilm, we actually link to Amazon.com because we also have a lot more reviews than LoveFilm in their databases. It just has to be the same XML format that they send in a response. But because you use a hypermedia type, because your client always tells the server, I accept application/vnd.com.lovefilm plus XML. the Amazon servers could have said, oh, that's a LoveFilm client, so we send them the LoveFilm XML format instead of the Amazon XML format, right? So overnight, they could have changed the link destination for these reviews to something on Amazon.com, and no client would break because they don't have hard-coded reviews links anywhere. They don't say, oh, I take some sort of ID number and attach it somewhere to a URL, and that never changes, and that's hard-coded in every single phone for the rest of these phones' lives, right? Because people never update their apps, and you have to maintain all this nonsense forever. Instead, if you tell your clients, just follow a link, you can change the flow that users go. You can direct them somewhere else. And the clients' authors don't actually have to do anything special in their code. They just fetch the href and fetch it with curl. So like I said, you can improve a bunch of things with namespaces, blah, blah, blah. Huddle. Huddle is a document store kind of CRM thing, document management system, I think. And they have, look how many link relations they have. Now, version history and thumb, that's actually their own inventions, and it shouldn't be called such a short name. It should be something unique, right? But you get the idea. You have a bunch of elements in here, and you just follow the links. So if you say, OK, this document has 2 actors, that's people who used the document or updated it. If I want to find out more information about Peter Gibson, I follow the href in the self link, because self is universally defined as the URL of the parent element, right? And the document itself also has a self link. It's that simple, and a client would always just follow URLs. Again, some improvements, like I said, the custom rels, etc. Now, maybe our online shop or LoveFilm API or Huddle API, they need to do breaking changes sometimes. And people say a lot, oh, I need 7 versions, and I need version types or something in my API. It's actually not true. If you follow this good old robustness principle, be liberal in what you accept and strict in what you produce, then, and I showed you this earlier, if there's all of a sudden 2 price elements, there's not really any reason for you to reject that, because you can assume it's still the same version, hopefully, of the media type that back when I wrote this client implementation, I read the spec off. So I can assume that the price is the correct price. I just blindly fetch the first price element and ignore everything else. Doesn't mean you can have discard everything else because you would destroy information. That's where things get complicated in practice. But just because there's a bunch of new fields doesn't mean your client can't still handle it. It can ignore the additional information. And only in rare circumstances you actually need to go from V1 to V2 for your API. And using the URL for that is actually not a good idea. Because first of all, that means it's 2 different resources when in fact you still have the same product. You just have 2 versions of representing it, right? 2 different representations of the same resource. And a machine could never bookmark those things. So a machine couldn't say, in my client, I fetched the product 2 years ago. Now I know version 2 of the API. I can do another get on the URL that I still remember and say, hey, server, I'm now capable of talking version 2 of our protocol. That wouldn't work either. Instead, do it like this. You have some sort of service. I fetch a product. And let's say in the specification of this shop software initially, we said, if something goes out of stock, the red stapler is no longer available, then another get returns a 410 gone. That indicates to the client the resource used to be there, but not any longer. That means my client, my smartphone app, can say, instead of saying, that product doesn't exist, it would say, that product is currently not available. That's the difference between 404 and 410, right? So one day, the boss walks into the room and says, I know you guys are programmers, but really we need to make money. So why do we even show an error message? Can't we have like some sort of pre-order, at least a notification of some kind? I want people to still buy the thing even if it's out of stock. That's a problem for my application, because my application assumes that if it returns a product to me, I can buy it. So my interface would say, buy now, in stock. So now I have to add new information to the media type that the product is actually not available. I say, For version 2 of the API, I have an availability flag. For clients with version 1 who request the product and it's no longer available, I can't just include that, because all of a sudden, the way the client needs to interpret the response has changed. It needs to know what the availability field means, because otherwise I would be changing behavior. I used to send a 410 gone when the product wasn't there. Now I'm sending an availability false. So that's one of the very, very rare cases when you actually need to version your API. In 99% of other cases, you can actually get away with just adding new fields because they don't change the semantics of your interface. Here I'm saying I understand version 2, and instead of showing me a 410 gone, it shows me the availability false because this field is documented in that version of the API docs. So if a client says I understand that version, then it's his problem if he ignores the availability field, right? Yep. And if you were instead to use the URL of a product or the URL of an API /v1 and /v2 products, my client code could never upgrade to the new version, like I said earlier. So that would be bad. Or imagine Drupal, PHPBB, they had some sort of API, but people have vastly different URLs out there, /API or API dot or something.com. And all of a sudden, all these URL schemas that would have to be the same. And imagine PHPBB authors came up with an amazing API, and then their competition came up with some sort of alternative API that turned out to be really shitty, and at some morning they say, why don't we just copy PHPBB's API exactly the same way? Then all of the clients that people wrote for one software would also work with our software, and more people buy our software. That's an idealized world, clearly. But you want these URLs to be dynamic. The only thing that the PHPBB and the vBulletin API, two forum systems, would have to have in common is they need the same documentation. They need to follow the same media type, but they can have vastly different URLs behind it. All the API clients need to know is this is the entry to your API, / or api.forum.com/. That's it. And then you just follow links, and these are defined in the media type. But what the URLs look like can completely differ between the different implementations because the clients are now dynamic. They follow links based on relations. And that's Hypermedia as the engine of application states. So why is that great? REST means we can evolve things, we can add new things. We hopefully don't have to break backwards compatibility too much. Like I explained earlier, I as a human can curl something and based on the link relations that are documented, figure out how something works. Because once I know that's the list of products, I know how to create one. I just post to it using the format described in the media type. And that's really easy to maintain. That really easily grows and scales well. Also in the documentation, you don't have to have 700 URL schemes or URL patterns documented anywhere. And it's good for clients as well. Plus, on top, you get all the cool HTTP features. But the thing is, this is nice to have. This actually helps you in real life immediately, right? Content negotiation, the ability to cache, authentication, just stacking some sort of OAuth bearer token authentication header onto something that actually a middleware that sits in front of your app handles for you for the authentication. That's something that immediately gives you as a developer value and potentially also your clients. This stuff only really pays off after a year or after half a year or once you have 10 clients consuming your stuff and you need to start making lots of changes. So you might now say, if I get all the cool things for free with an HTTP service and I can totally ignore the Hypermedia stuff, isn't there one last killer feature in REST that makes it totally amazing and totally worth my while that I can justify spending time on? And the idea is, of course not. REST is about, Roy Fielding said this in many of his blog posts, etc., is about software design on the scale of decades. And some of these things are not helpful with short-term efficiency. But unfortunately, as humans, we're not very good at thinking in the long term. That's actually why you propose these constraints, because at least then you have something to follow and you don't need to think about it yourself, right? And the idea is about evolvability over time. In real life, many of us write a system, and once the next guy takes over, 5 years later and has to make changes to it because it's all of a sudden broken, we don't even work at the same company anymore. So it's a lot about caring. It's a lot about, do you want your stuff to be around in a couple of years? Do you want to make life really, really easy for your clients, for your service? And we all know that it's nice initially to cut corners, but it always comes back to haunt us and bite us in the back, right? So don't do it. Give hypermedia a chance. If you want to learn more about this, there's a great book that I can recommend, RESTful Web APIs. I've talked about Leonard Richardson earlier. Mike Amundsen is a very cool guy. There's a conference in, well, that's the problem with that conference. It's in Greenville, South Carolina. It's not as bad as it sounds. It's actually a cool, cute little city. In September, I think, restfest.org. If you want to learn more about this, you should come. If you instead just want to read that book, get that book. If it's one book, make it that one. If you ever wondered how you would model the coffee shop, Starbucks, whatever, ordering flow as an API, that's your article. And there's a bunch more books. Don't like this one so much. This is really cool. This has some questionable advice, but they're still all kind of useful if you want to learn more. With that, that's the end. That was my presentation. This QR code gets you to Joined In, where you can rate this presentation and also download the slides, so you don't have to type anything or photograph anything. I said that very early, didn't I? So yes, thank you. Hope you enjoyed this, and have a lot of beers now.